Problem 3 states that the eye of a hurricane passes over Grand Bahama Island in a direction of 60 degrees north of west with a speed of 41 kilometers per hour. 3 hours later, the course of the hurricane suddenly shifts due north and its speed slows to 25 kilometers per hour. How far from Grand Bahama is the hurricane 4.5 hours after it passes the island? So what we're going to do here is take a look at this problem vectorially and try to solve for that distance in the end by using the vector component properties that we can glean from this problem. We've given some magnitudes, some directions, some durations. So let's take a look at what pieces that we can use to solve the problem. So the first thing that we're going to look at here is the fact that after 3 hours of moving at 41 kilometers per hour, the hurricane is some distance north of west of the island. So to calculate this, what we need to do is take that 3-hour period of time and multiply it times the rate that the hurricane was moving. So for that first 3-hour period, the hurricane was moving at 41 kilometers per hour. So 3 hours times 41 kilometers per hour now gives us a magnitude of 123 kilometers of distance that the hurricane has moved in that period. So now what we do is take advantage of the component method of breaking that vector down, that 60 degrees north of west, into its x and y components to determine what the total direction is during this period of time. So it's very simply taking the cosine and the sine of the angle and multiplying it times the magnitude. So in both cases we have a magnitude of 123 kilometers. In the x direction, if we take the cosine of 60 degrees and multiply it out, cosine 60 degrees, its value times 123 kilometers gives us a negative value of 61.5 kilometers. Okay, and that makes sense because if we look at this vectorially, okay, now the other component, the sine of 60 degrees times that 123 value gives us a positive, in this case, 107 kilometers. So that becomes our two component values that we use to determine what is going on during that first 3 hours. Now, for the last hour and a half of the 4.5-hour period that they've asked us to look at, we need to determine what the rate is as far as the distance based on the rate of 25 kilometers per hour that the hurricane has slowed down. So for an hour and a half at 37.5 or at 25 kilometers per hour, we end up with 37.5 kilometers of distance during that last 1.5 hours. So now we gather all of our component terms and we can put them into a table format and determine what our resultant is, and then later the angle. So first we put our displacements in a column format, 123 kilometers and 37.5 kilometers. And if we look over here, in the center portion we have the x component eastward, negative 61.5, and the y component, a plus 107. Okay, for the other term we have a 0 x component because the direction that the hurricane is moving, plus a y direction of 37.5 kilometers. So now all we have to do is sum our x component terms, which comes out to negative 61.5 kilometers, sum our y component terms, which gives us 144 kilometers. So now we can take the Pythagorean theorem and use the x and y components. 61.5 kilometers squared 144 kilometers squared. When we square them, add them together, of course we lose the negative sign in the x terms, we end up with 157 kilometers from the island. So for that total 4.5 hour period, with the rate of speed changing and the hurricane changing direction, we end up then 4.5 hours later, the hurricane moving 157 kilometers from the island.